Hello viewers, in today's class we are going to discuss one important and conceptual problem from limits, right? So here we'll solve this problem, and here we are given that limit x tends to 0 plus this positive sign shows that we have to find the right hand limit of this function when x approaches to 0, right? So here we have limit x tends to 0 plus e raised to x signum of x minus the square of greatest integer of cosine x divided by 1 plus greatest integer of x plus 1 is equal to log of lambda, where lambda belongs to the set of real numbers. Then we have to find the value of lambda, right? Okay, so now this limit is equal to log of lambda, and we have to find the value of lambda. So what we will do, we'll try to find out the value of this limit, and then we'll equate that value to log of lambda to get the value of lambda, right? And here there is one important thing, that is in this function, the signum function and the greatest integer function both are involved, right? So here let us call this limit as L, right? So since we are approaching towards x is equal to 0, from the right of x is equal to 0, right? Because here we have the positive sign. So here we can take x is equal to 0 plus h, right? And this 0 plus h is very close to x is equal to 0, but 0 plus h falls towards the right of x is equal to 0, right? So here x is equal to, we'll take x is equal to 0 plus h, where h is a positive quantity and h is greater than 0, right? And moreover, here h is a very small quantity, right? So now let us write this limit in terms of h, right? So we have L is equal to limit, and we have h tends to 0, and we have e raised to x signum of x, right? So we are taking x is equal to 0 plus h, so we can take x is equal to h, right? And when x tends to 0, obviously h tends to 0, right? So now here we'll write e raised to x signum of x. So we have h and signum of h, because x is replaced by h, and here we have greatest integer of cos h, and here we have the square, and here we have 1 plus greatest integer of h plus 1, right? Okay, so now what we will do, we'll first take this signum function, right? See, here we have signum of h, right? And see, h is a positive quantity, right? So we define signum of x as plus 1 whenever x is greater than 0, and signum of x is 0 when x is equal to 0, and signum of x is minus 1 when x is less than 0, right? And here when h tends to 0, then signum of h is equal to 1, right? Because h is a positive quantity, and whenever we have x a positive quantity, then signum of x takes the value plus 1, right? Okay, so now let us decide the value of greatest integer of cos h when h tends to 0, right? So here we'll make use of the graph of cos function, right? Now let us take a rough sketch of cosine function here. See, the cosine function, it goes like this, right? So here we have the cosine function, and here we have positive 1, and here we have negative 1, right? And here we have 0, right? So when we have x is equal to 0 plus h, right? So here 0 plus h lies in the right neighborhood of x is equal to 0, right? And see, if we take this point as 0 plus h, that is h, right? Then the value of cosine function, it goes like this, right? So here we have the value of cosine h, which is smaller than 1, right? So when we take x is equal to 0 plus h, which is simply h, then the value of cosine h is smaller than 1 but greater than 0, right? So when h tends to 0, then cos of h, right, this cos of h is greater than 0 but it is less than 1, right? So the definition of greatest integer function gives us the greatest integer of cos of h, it should be equal to 0, right? So when h tends to 0, it means h is a very small quantity, but h is positive, right? So cosine h has a value which is less than 1 but greater than 0, right? So cos of h, it lies somewhere here, right? Which is just below uh, plus 1, right? So the greatest integer of cos h must be equal to 0 when cos h lies between 0 and 1, right? So now let us take this term, right? We have taken signum of h here and cosine of h, greatest integer of cosine of h. Now let us take greatest integer of h plus 1, right? See, h lies between 0 and 1. And if we add 1 throughout this inequality, we'll get 1. 0 plus 1 is 1. Here we have h plus 1, and here we have 1 plus 1, 2. Right? So here 1 plus h or h plus 1 is slightly greater than 1, but it is less than 2. Right? So the by definition of greatest integer function, the value of greatest integer of h plus 1 must be equal to 1, right? So now this limit can be written as limit h tends to 0. We have e raised to h, and here signum of h is equal to 1. So here we have plus 1 because signum of h is plus 1, and minus here we have greatest integer of cosine h is 0. So we have 0 square, and here we have 1 plus 1, right? So now we have limit h tends to 0, and we have e raised to h, and here 0 square is 0, and here we have 2, right? Now when h tends to 0, then the limit of uh, e raised to h is e raised to 0, and it is divided by 2, and e raised to 0 is 1, so this is 1 over 2, right? So the value of this limit is equal to half, right? And in the given problem we are given that this limit is equal to log of lambda, right? So we have log of lambda is equal to half. So by the definition of logarithms, we can now write lambda is equal to e raised to half, right? So the value of lambda is equal to e raised to half, right? So here we have used the fact that if we have log of a is equal to b, then a is equal to e raised to b, right? So the value of lambda is e raised to half.